Good morning, everyone. So, is no one representing a sports team right now? Is it just me? Yankee fan myself. Come on, guys. It's Spirit Week. What's everyone's favorite sports team? Why don't you say it in chat? Because right now it's just Paige and I talking about mathematicians and physicists. Yankees. Good. All right. Jess can stay. There are wrong answers to this, by the way. You guys don't want to get the first official write-ups remotely. I don't know how you do that, but make sure you choose the right team. My favorite team is the basketball players. Which basketball player? Again, there's a right answer to this. Who's your favorite basketball player? All of them. Come on, you have to have a favorite. Sports are gross. One of my softball players making this comment. I might just choose to ignore that. Kansas City. The Royals? The Chiefs? All Kansas City teams? What do you like? You love the moment the basketball players just kind of throw it at the hoop. All right. Abby, you should have a favorite softball team. And if Olivia's here, also, what's her favorite softball team? Mine is Oregon. I like Oregon. All right. We have 13 people right now. Red Sox. Oh, God. That is one of those incorrect answers. Ugh. Imagine watching sports. Oh, Abby. Alright, we will get started in just a moment. Obviously, the school is doing a virtual Spirit Week. If anyone wants to, obviously, I know I can't see you guys, but definitely, Thursday, share pictures of your pets and stuff. I'll bring my cats onto the stream. You can see how they're doing, and so forth. Oh, Jeopardy's the best sport. That's true. Jeopardy's pretty good. Yesterday, I had you guys finish a proof. We will go over that. I got it started for you. Then I wanted to take a look at one of the Regents proofs. I mentioned that yesterday. And then we will, continue practicing proofs. Like I said, Thursday is probably the day we will kind of revisit that Kahoot, and that is going to wrap up at least this unit, at least doing this unit remotely. We'll jump right into circles after spring break. We might even take a look at the review sheet maybe tomorrow. But, we've done a lot of proofs up to this point. I want to finish the one that I gave you. We'll do the Regents one. And so forth. And then I have one there in the worksheet for you if you guys want to try one completely on your own. So that's kind of the plan for the rest of the week. I think Friday, although Friday does have a Spirit Day, I'm pretty sure that's when spring break is supposed to start. And during spring break, obviously, there's going to be no streaming. This should be uniform through all your classes and so forth. So if you have any questions about any of that kind of stuff, please just throw them in chat, and I'll be sure to answer them. No, we're not having classes over break. Not definitely not for this class. You shouldn't be on your other classes as well. All teachers were told that spring break should be just that, break. Just stay inside during your break, but maybe get caught up on work. But as far as we were told, haven't heard anything differently. So we will assess that when we get some certainty. But as far as I'm aware, spring break is spring break. All right. So we're just saying no Cuomo. I haven't heard this. I don't know. Like I said, things change so quickly that I probably just didn't hear about this. I will wait until Mr. Jenny or Mrs. McGrath give us more information on that. But I haven't heard anything. The last thing I heard was that spring break teachers should not be teaching. But if that changes, then so be it. We're going to get started. Let me just get the proof that I gave you yesterday pulled up. This one. I did get it started. If I am just going to start jumping right into the statements and reasons and so forth, because this is the one that I'd asked you to try out writing out the statements and reasons yourself, and then it's kind of seeing where we can go from there. So you should have it written down, so I am going to go a little quick through it. We did the analysis of this already. We had to prove that triangle MQN was congruent to triangle ORP. So we got MNOP as a parallelogram. Angle MQN is congruent to angle ORP. That's a given. And let me just kind of double check what that was. That was these two angles in here, and everything else kind of came from the other two. So I can say that MN is congruent to PO. And then looking at my diagram, it looks like I also marked them as parallel because I know I'm using alternate interior angles. So in the same justification, I could also say that MN is parallel to PO. And the reasons are, in a way, the same. I'm just going to say, in a parallelogram, opposite sides are congruent and parallel. That way I can just save myself a little bit of writing. So I am kind of clumping these two together. If these boxes weren't here, I would probably just write this in the same step. But in a parallelogram, opposite sides are congruent and parallel. That way it just saves me a little bit of writing. If you didn't do that, that's obviously fine. You could have just wrote them separate and just said, in a parallelogram, opposite sides are congruent. In a parallelogram, opposite sides are parallel. Remember, we have a little bit of flexibility in how we want to word these things. I just like to word them. That saves me just a little bit of time. And that was a side. So I have a side. I have these angles. Looks like I just need angle 1 and angle 2 now. So angle 1. And I can jump right to this because I've stated that the two lines were parallel. And then it's that phrase we've been writing all year long. If two lines are parallel, then alternate interior angles are congruent. That's all with step 5. I just needed a little bit more room, so I had to write it down there. And I think that's everything. Let me just double check. The given gave me 1. That gave me an angle. This was a side, and that was an angle. So It's not angle, angle. It's not angle, side, angle. It's angle, angle, side. So triangle MQN is congruent to triangle ORP. Angle, angle, side. So that's the one that I gave you yesterday to do. Hopefully you guys did pretty okay with that. I kind of did mention all of, like, the loopholes. I just didn't write it out for you because we did the analysis part. And yeah, if there's any questions with that, let me know. If you had done it maybe differently, wrote something differently, just throw it in chat so I can see if you ran into any issues. If not, we're going to move on. I am going to do a Regents one, so I would suggest taking out a blank sheet of paper because I am going to show a completely different one that is not on here. Just because the Regents tends to ask things in a little bit of a different way, and I want to make sure that we're accustomed so we can see questions that are asked in this different way. But not seeing any questions, so hopefully everyone has a separate sheet of paper out, and writing this out won't take tremendously long because this is the whole thing, and then the rest is just blank paper. So best to draw a parallelogram. Well, actually, it's just a quadrilateral. The given says it's quadrilateral ABCD with diagonals AC and BD bisecting each other, and that angle 1 and angle 2 are congruent, and they labeled angle 1 and angle 2 for us. So I do want to I know it's going to take a second to copy that down, especially the shape. You don't necessarily need to write this part down unless you want to, because you are going to write that as a given anyway. So if you do want to write it down, just throw it in your statement. Yeah, graph paper is fine. Any blank paper is going to be fine. I would just suggest giving yourself the entire page because you're going to probably have this at the top, and this proof is going to take. I mean, this is what my page looks like. It's a bit of a longer proof, but depends on how big you write. Now, like always, I do want to look at what I'm trying to prove before I really jump into this. So as you're copying it down, you can just listen because the proof just says triangle. We have to prove that triangle ACD is an isosceles triangle and triangle AEB is a right triangle. This is the first time, and this is the first time I've ever seen this, a Regents do this, that they asked you to prove two different things. Never seen it before, but there's no reason why they can't ask something like this. It's unusual, and I know it confused some students, but I'm not sure why it should. Just treat it as two separate things. You have two separate goals. Doesn't matter which one you do first. You just got to make sure you end up proving correctly both of them, rather than just a single thing. It's just kind of those little curveballs that they can throw at you. We can't predict what the Regents is going to do to us, but this could be one of those things. We have to be accustomed to adjusting to the little changes that they're going to do to us. And this is one of those changes. So I have two kind of goals in mind. I need this ACD triangle to be isosceles. I'm going to highlight that. So we're going to try to prove that this is isosceles, as well as AEB is a right triangle. So I'm going to do a separate highlight to AEB. Here's AEB. So we need to prove that the yellow one is isosceles and the green one is a right triangle. Now, I'm not 100% sure if it is obvious to anyone or not, but your best bet in accomplishing this proof is to show that ABCD is a rhombus. If ABCD is a rhombus, which in order for these things to be true, this thing has to be a rhombus. And if it's a rhombus, well, that means the diagonals are perpendicular. And then right there you have that is a right triangle. If it's a rhombus, all sides are congruent. Then you know that ACD, that triangle, is isosceles. So that seems like a really good goal. And it's not explicitly asking you to do that. It's not saying prove it's a rhombus, but we have to kind of keep in the back of our mind, like, if I know it's a rhombus, this is incredibly easy. So that really should be the goal. Let's prove that this thing is a rhombus. We're going to try to prove it, but it has to be a rhombus in order for these things down here to be true. So let's dive into it. And here's one of the other things they kind of throw at you. In no way do they say that this is a parallelogram. And this is one of the things we have to look out for. Look at the very first sentence that they write in the given. Let me just erase that. So it's the part that I've highlighted right now. Quadrilateral ABCD with diagonals ACBD that bisect each other. If the diagonals in a quadrilateral bisect each other, that automatically makes it a parallelogram. They have indirectly said it's a parallelogram. I have a lot going on right here. Let me clean all this up. Right here. They have told you it's a parallelogram without explicitly saying it's a parallelogram. Because remember, it only takes one property to show that's true to say it's a parallelogram. So instead of the given being a parallelogram, they kind of just threw this at you instead by saying, hey, these diagonals are bisecting each other. Don't forget to say that it's a parallelogram, though, which is going to probably be our best bet. So it's very easy to show that this is a parallelogram. So we have, these are congruent to each other. And now we can prove it's a parallelogram right off the bat. Now do we have enough information to say that they are congruent to each other? Sorry, not congruent. Do we have enough information to say that they are, that this shape is also a rhombus? We know why it's a parallelogram. Do we know why it is a rhombus? If I go back, whoops, not that one. If I go back, right here, we haven't used this one in a long time. I don't think we've ever actually used it in a proof. We definitely didn't use it in coordinate geometry proofs, but we have exactly this. That other given was angle 1 and is congruent to angle 2. So if the diagonals bisect the opposite angles, that means it must be a rhombus. And that is exactly what we are getting right here, that these are being bisected. We do need to kind of show that maybe these are also bisected, but that shouldn't be too difficult because those two angles that I just marked are also going to be congruent because, well, it's a parallelogram, alternate interior angles are congruent. That makes all four angles congruent to each other. So there we can kind of prove it's a rhombus. And now if we know it's a rhombus, we can easily prove this thing in yellow. Analyzing this is, I don't think, terribly difficult. I think this is a proof where writing it all down might be more challenging. Let's start with that. So, statement, reason. 1. Quadrilateral. A, B, C, D. With diagonals AC and BD that bisect each other. Angle 1 congruent to angle 2. Given. The second statement should be, say that ABCD is a parallelogram. Because we're trying to get to the rhombus, let's say it's a parallelogram right off the bat. Triangle. Oh, not triangle. ABCD is a parallelogram. Then the reason. Why do we know it's a parallelogram? We know it's a parallelogram because the diagonals were bisecting each other. So you can put this into a conditional statement. A conditional statement being an if-then statement. Say, if a quadrilateral has diagonals bisecting each other, then it's a parallelogram. You can word it really any way you want, as long as you mention something about those bisecting diagonals, and that's why it's a parallelogram. You can really word it however you want. I'll use that if-then statement. If a quadrilateral has diagonals bisecting each other, then it is a parallelogram. So now I think we can jump right into the rhombus. Now I did mention we could prove these are congruent. Then we truly would have the diagonal bisecting both angles. But I think it's going to be a little unnecessary. I think if we have just the one, we would be good to go. So we can jump right into saying that it is a rhombus by saying that these diagonals are being bisected. So ABCD is a rhombus. Then another if-then statement. If a parallelogram has a diagonal that bisects an angle, then it is a rhombus. And don't get overwhelmed by kind of this writing, because it is a lot. It's a little bit more writing that we've been doing in a proof. But like I said, you have flexibility in exactly how you word these things. In the past, we've had a lot of narrow phrases that you kind of had to say word for word. That's not necessarily the case. As long as you can explain, even in your own words, why you know it's a rhombus, and you're using the properties that present themselves in the question, you'll be fine. But there's an infinite ways you could word these things that are going to be correct. This is just the way I'm choosing it, because typically using these conditional statements are a really good way to go. Now we got to jump into the fact that, well, what we're trying to prove. So now I'm going to go back to what I'm trying to prove here. I have simultaneously two different things. And like I said, it doesn't matter which one you do first. I think the first one's going to be slightly easier. Let's explain why ACD is an isosceles triangle. Well, we just stated that the whole thing is a rhombus. So if the whole thing is a rhombus, all sides in a rhombus are congruent. And these are the two things that we need right here. At least that's one way you could do it. You could go with the parallelogram piece and say that angle 1 is congruent to this angle right here. And then you could say that angle 3 and 2 are congruent because you have opposite angles congruent and they're being bisected. And then you have both angles congruent. That's an additional 2 steps, though. We can get right to an isosceles triangle in basically 1 or 2 steps. Say that these two sides are congruent. Say the triangle is isosceles. So that's kind of the route I'm going to go. But I do need to say that those two line segments are congruent. I'm going to write this. Actually, no, I'm not. AD is congruent to CD. Now you could say all the other sides are congruent because it is true, because all four sides are congruent, but these are the two we need specifically for triangle ACD. All sides to a rhombus are congruent. Step 5. That's enough information to say that triangle ACD is an isosceles triangle. And then we've proved this. We've proved this before. If two sides to a triangle then it is isosceles. And I am running out of room a little bit, so I might need to move everything. But we now need to get to why the next triangle is a right triangle. So this is a little bit different. We've done one part of the proof. This is one of them, but now we need to state why this one is a right triangle. Yeah, we might just need to use a separate sheet of paper. Not sure why they gave us such little room on this, but we'll make do. So the best way to prove that this is going to be a right triangle is, let's use the property of the diagonals. The diagonals are perpendicular to each other. Now we do need to take that definition quite literally, because perpendicular is the thing that tells us that they're right angles. We can't just jump and say that this angle right here, that's the one we want, is a right angle. Why do we know it's a right angle? We know it's a right angle because the diagonals are perpendicular. And if there's anything missed in this proof, it would be this step. This would probably be the most forgotten step in this proof, is forgetting to state explicitly that the diagonals are perpendicular. Everyone wants to just jump to say that, oh, this angle, I'll call this angle 3. Angle 3 is a right angle, and then people would write an incorrect reason saying the diagonals form right angles, which is not technically the definition. The technical definition is diagonals are perpendicular to each other. So that is what we need to say. We're going to state that those diagonals are, in fact, perpendicular. BD is perpendicular to AC. In a rhombus, diagonals are perpendicular. And like I said, that would be the most missed step. That's the motivational lizard. Interesting. Now we can say that they're right angles, because perpendicular lines form right angles. This should be nothing new. We only need one, though. You only need angle 3. It's the only right angle you need. You don't need to state all 4. You don't even, because you don't need to say that angle 3 is congruent to anything. We just need to say that it's a right angle. That way we can say it's a right triangle. So angle 3 is a right angle. Perpendicular lines form right angles. And lastly, we can say, step 8, triangle AEB is a right triangle. Motivational lizard on YouTube. Do I want to watch this? Triangle AEB is a right triangle. And then anything to justify that, as simple as saying that a triangle that contains a right angle is a right triangle. I like that. A triangle that contains a right angle is a right triangle. Which I would say up to this point, maybe one of the most difficult proofs we've probably ever done. This was a 6-point question, though, because there's typically 2 of them on a Regents for a total of 12 points. I think they've taken 1 away, so there's typically only 1 now. But this is an example of what a 6-point proof would look like. And by no means was this easy. We got to the end with 8 steps. There's a lot of little details that are definitely difficult to do with this entire proof. The analysis alone was challenging because you had to know it was a parallelogram and a rhombus. Because nowhere in the given or what you're trying to prove, it doesn't even seem like it is anything about parallelograms, but it had everything to do with parallelograms and triangles. There are other methods of doing this. Typically, these 6-point questions do have more than one solution. It is possible to do this proof completely without the rhombus. You have to do a lot of triangle proofs, a lot of CPCTC, but it does work. That is a completely different solution because I think that is actually how I did it the first time I did this proof. And I knew right away, I'm like, this can't be right because I think I ended this proof with 18 steps or something like that when I first saw this question. It worked, but 18 steps is obviously unconventional. This is going to be the easiest way to do it, is just show that it's a rhombus. But there are other ways because we could have proven a lot of these triangles are congruent based on this information. So with that, how do we feel? How do we feel with that proof? Like I said, this is definitely one of the most challenging proofs that we've done. You need cotton on heyday. I'm not trading you my cotton. It's mine. So with that, we can end with maybe one more because we have 9 minutes left. We'll do a easy one. So the 2 on this page are actually a lot easier. I put a star, or what tried to be a star. This is the one that I'm going to assign for you guys to do completely on your own. So I'm not even going to do any analysis on it. That's the one that you can try completely on your own. So feel free to do that one tonight, and I'll show us the solution to that one tomorrow. But to end off, let's just have a little bit more practice and see one on our own. This is one, if we were in class, I'd probably have you do this one on your own, but right now we only have 8 minutes. I can't really monitor how our progress is while doing it, so I'm just going to jump right into it. This proof actually isn't too bad either. They just want to prove that 2 triangles are congruent to each other. So triangle SWT is congruent to triangle SWV, this triangle right here. And the given is the whole thing is a rhombus. That is a great given. Like we've mentioned it before, if that is your given, you have all 8 of these you have the 5 from the parallelogram, and you have the 3 from the rhombus. So you have multiple ways you could really try to prove that these triangles are congruent. Let's see what the easiest solution for us is going to be. So just by looking at it, right off the bat, SW is reflexive, so we have a side right away. Using properties from the rhombus directly, You could use right angles, I think, saying that these two sides are congruent because all sides for a rhombus are congruent. And I would actually avoid the right angles because you have to state that the lines are perpendicular. You could skip a step by just saying these two angles are congruent because diagonals in a rhombus bisect their angles, just like the property we used before. So that property of a rhombus is becoming far more useful to us now that we're doing these statement reason proofs. Wasn't really a useful property in coordinate geometry, but here it is. And that's it. You have side angle side. You can completely skip the right angles. We're not going to need that property. So, let's jump to it. STUV is a rhombus. Given. Let's get that reflexive property out of the way. Yeah, we could do. I think with this specific proof, the fact that you know it's a rhombus, I think you could do all of the triangle congruency theorems. You could do side, side, side. You could do side, angle, side. You could do angle, angle, side. You could do angle, side, angle. Yep, you could do angle, side, angle. You could do all of them. There isn't one that you can't do for this one. You could even do hypotenuse leg because they're right triangles. I just chose side, angle, side because that's what I thought were the easiest ones. But yes, you could do this one every different way. It's because this is one of the best givens. Obviously, the best given you could ever get is a square because then you have so much available to you. But knowing things that are parallelograms, rhombi, great pieces of information. Reflective property. Whoops. Now I'm going to go with the all sides congruent or the angles. I'll go with the angles, so I write it in order, although we know we don't have to. Angle 1 is congruent to angle 2. In a rhombus, diagonals bisect their angles. I know my Y here is getting in the way, so I'll just shift that up so you can see it. In a rhombus, diagonals bisect their angles. Now I'll go with the sides. ST is congruent to SV. In a rhombus, all sides are congruent. There's my last side. Perfect. We're right at the end. Triangle. Triangle SWT is congruent to triangle SWV. And we have side, angle, side. So we probably went from doing the hardest proof probably to doing one of the easiest proofs. And you could see something this easy on the Regents. If you do, it's probably just going to be a 2-point question. So just keep that in mind because there's so many different avenues you could go to solve this one. You really just need to know, as long as you know your properties of the rhombus, you are really good to go. That's going to be the most important thing. That sheet that I keep using as reference, I keep pulling up, those are kind of the properties that you need to know. If you know them, you'll be really, really good. But that one, definitely much easier. So we will probably do only one more proof for the unit, maybe two, because I think we'll look at the review sheet as well that I gave you guys. Even though we're not going to be taking a test, not remotely, we will we'll take a look at I think I put a proof in that review sheet. So we'll take a look at that when we get to that, which will probably be maybe tomorrow. I'll probably go over this. We'll see how much of the review sheet we can go over in 40 minutes. And then on Thursday, we would do the Kahoot. We'll try that again. Hopefully our results are better than the first time. I think it'll be fun. It'll be a good way to end the week and so forth. If you guys have any questions, please let me know. We will conclude it right there. We only have about 2 minutes left. This is the proof that I will ask you to do on your own. So, you can get some extra practice at home and so forth. Again, if you have any questions, please throw them in chat. Try to represent your school spirit. Wear your favorite jersey or something. Unless it's a bad team. No Red Sox. No, none of that. But you guys have a nice day and so forth. Am I planning on giving you nothing over break? I don't know yet. I am waiting to hear what other teachers plan on doing. And what Mrs. McGrath guides us to do, what Mr. Jenny suggests that we do. So I'm not going to answer that just yet. We do have a meeting tomorrow, all the teachers, so I will let you know maybe if any information there has been said about that. But that meeting's at 10, so I might be a little either late or really early at sending out that remind. If I don't send out that remind, I'll still be streaming tomorrow. I just might not send out that remind because I'll be in the middle of a meeting. But